Hey y'all, today we're going to be talking about friction and gravity. It comes from indicator 8P2A5, which says to analyze and interpret data to describe and predict the effects of forces, including gravitational and friction, on the speed and direction of an object. So basically, how does gravity and friction affect how things move or don't move for that matter? There is a little video for you guys to click on. Bill Nye, he's going to talk to y'all about friction, which is a pretty cool video. If you like Bill Nye, go check it out. Otherwise, let's continue talking about friction. So, friction is the force when one surface exerts the force that one surface exerts on another when two rub together. So, this force goes against motion. So, if motion's going one way, friction is going the other way. All right, it can slow things down or just stop it entirely. It makes it difficult to start objects moving. If something is stuck that you're trying to push, it's because there's a lot of friction, probably because it's heavy. It's got a lot of mass, so the mass is pushing down on it, on to the the weight is pulling it down to the earth, and it's producing a lot of force going down, which is making it a lot of increasing the friction, making it harder to push. So if you want to get something moving, whether it's a bookshelf, a table, a chair, whatever you're pulling, dragging, sliding across the ground, you need to make sure you apply enough force to overcome the force of friction to make it and start moving. So there's two factors that determine the amount of friction: the kinds of surfaces they're touching. So if you have two pieces of silk touching each other, there's not going to be a lot of friction. It's going to be smooth. Or you can have two pieces of sandpaper touching, and there's going to be a lot of friction because those are rougher. So the rougher the surface, the more friction there is. The smoother the surface, the less friction there is. Duh, that makes sense. Friction can be reduced by smoothing the surface. So you can sand stuff down to where there's less friction. Um, you can also put wheels on things. That's great if you're trying to make things, because pushing a car is hard. Imagine taking the wheels off of the car and it's just laying on the ground. Try pushing it then. That's even way harder. So if you put wheels on something, it's going to make it easier to push. Or if you grease it up, make it slippery. If there's fluid on the ground, you say, there's a spill in the hallway. They put out the little triangle sign. What's that? Caution when wet. Cuidado piso. I don't. What's the Spanish version? It's on the sign. Go look at the sign. You'll see. Yeah, there we go. All right. So the force pressing the surface together, the greater the force pressing. So like I said, if there's more mass, there's more force pushing down. It's going to produce more friction. So the greater the force pushing the two surfaces together, the stronger the friction. As an object gets heavier, the force of friction between the two surfaces becomes greater. So the heavier it is, the more friction there's going to be. To move a heavy object, you need to apply more force to it to overcome the friction between those two surfaces. So if it's heavier, it's got more mass. Force is equal to mass times acceleration. So you're going to need to apply more force to overcome the mass in order to accelerate, because now there's more mass, which means there's going to be more friction. So got to either give it more force, sand it up, grease it down, something. But at the same time, is friction useful? We know it's like, well, friction is hard to make things start. Well, friction also allows you to walk across the floor because you need to have a grip, that traction as you walk, or you're just going to, be moonwalking in place, which is, ooh, this looks cool. Look at him. Instead of walking. That's with friction. So it allows you to walk across the floor. Without friction, your shoes would simply slide across the floor. What a fun time. Friction allows you to strike a match. That friction, because a byproduct of friction is heat. It allows the flame to ignite. So friction is useful. How could friction not be useful? Well, it wears down the tires over time and becomes more because you need friction when you're on the road in order to propel you forward, just like you need friction with your feet on the ground in order for you to walk. So you need those tires. When the friction wears away at the tires, and you're left with bald tires are bald and they may be flat. So is our love, but that is that. That's a song from the movie Michael. It's about an angel starring John Travolta. Gears inside machines wear down because of friction. So same thing, whether your tires wear down, the gears wear down. So friction, it's good, but it's got its downfalls as well. Now we're just going to move on, talk about gravity, because this indicator is about friction and gravity. So friction, you need, it depends on two things: the type of surfaces and the amount of weight it has, how much mass is, the object has. So that's what's important about friction. Gravity, that's what we're talking about now. Gravity is a force that always attracts or pulls objects toward each other without direct contact or impact. So you don't need, there's not a string attached to this pin, but gravity's pulling on it. And when I let go, there wasn't a string. It's not magic. It's gravity. So it doesn't have to have direct contact in order to pull something down. Gravitational attraction depends on two things as well. It depends on the mass and the distance. The closer things are together, the more attracted they are to each other. The farther apart, the less attracted. Long distance relationships, they're hard. It's hard. They're less, you get less attracted to one another. You don't see each other as much. But when you see each other, you're in closer contact, you're more attracted to something. Same thing goes with moons and planets and stuff like that. The closer they are, the more attracted they are to each other. And the bigger they are, the more gravitational force they have. So objects on Earth are pulled toward the center of Earth. The force of gravity, like all other forces, can cause changes in speed of objects. So we're talking about, how does friction and gravity affect speed of objects? Well, friction slows it down. Gravity can cause things to speed up. You drop it and you jump out of an airplane, you start falling, and you're going to accelerate at 9.8 meters per second squared until you reach your terminal velocity. But gravity's going to cause you to go faster and 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 faster. Continually increase as you pull downward. Until if air resistance is ignored, all objects will speed up the same rate. So if you take away the air resistance, a hammer and a feather will accelerate at the same rate. If you don't have when you do have air resistance, sometimes those things fall at different rates. This paper and this pen, because there's more air resistance on this paper than on this pen. So it falls down quicker. But if I took away all the air in the room, number one, I couldn't breathe. I'd probably die. Number two, they would fall at the same rate. Gravity can also cause objects that are thrown into the air to change direction. So we're talking about acceleration, speeding up, slowing down, and changing direction. We know it can cause it to speed up as it falls, but it can also cause it to change direction. I'm throwing it up in the air. It should go up. Objects in motion stay in motion. It should continue to go on its path. Wait, I just threw it up. Why is it coming back down? It's because of gravity. Gravity is making it come back down. It's making it change direction. I threw it up in the air. Now it's coming back down to Earth. Ooh, why am I throwing a ball when I've got throwing this pin when I've got my lovely ball here? That's gravity. It's pulling it down. Whee! All right, you get the idea. The pull of Earth's gravity keeps the moon in orbit. So it doesn't just continue to fly, because objects in motion stay in motion. It's got inertia and wants to go in a straight line and fly off into space, but Earth's gravity keeps it tethered and makes it loop around the Earth. Is this a video? No. Okay. And that's all of our notes. I hope you enjoyed. Ta-ta, toodaloo, bye-bye. Oh, go back and watch the Bill Nye on friction. It's good.